Welcome, my name is Dr. DrWedding, and this is DrWedding DC14. LEDs and calculating current limiting resistors. In this video, you will learn how a light-emitting diode works, why you need a current limiting resistor, and how to calculate the value of a current limiting resistor. LED stands for light-emitting diode. An LED is different from other diodes because it will light up when current is flowing through it. There are a few schematic symbol variations shown below, but they all have a diode symbol with arrows exiting the diode to represent light. All diodes, including LEDs, have two ends, an anode and a cathode. Diodes are directional, so they only pass current from the anode to the cathode, and they block current from moving from the cathode to the anode. To light up an LED, it must be forward biased, meaning the voltage on the anode must be greater than the voltage on the cathode. This will cause current to flow in the same direction as the arrowhead created by the schematic symbol. When current is flowing in this direction, the resistance of the LED is 0 ohms, and the LED will produce light. If the voltage on the cathode is greater than the voltage on the anode, the LED is reverse biased. Current will try to flow through the diode backwards, and the LED will block the current flow. Think of the bar on the cathode side of the arrowhead as a brick wall that stops current. In this state, the LED has infinite resistance and it will not light up. Because the LED will only work in one direction, you need to know which side is the anode and which is the cathode. The cathode is marked on the LED in some way, such as a flat spot on the round base, a shorter lead, or both. The diodes discussed in the previous video were power diodes. These diodes are a small part of a larger, more complex circuit, such as a bridge rectifier or a flyback circuit. Therefore, the examples had multiple resistors in series with the diodes. LEDs are much easier to use. They are often used as lamps or as an output indicator of a digital circuit. An LED only needs a power source, a single current limiting resistor, and the LED. This makes the calculations very simple. When a power diode or an LED is forward biased and is conducting, it will take some of the voltage from the supply. This voltage toll is called the threshold voltage. The threshold voltage of an LED can change depending on the manufacturer, the color, the size, and other factors. Some examples are shown on the table below. Normally, the threshold voltage of a standard 3mm or 5mm LED is about 2 volts. As the current through an LED increases, the brightness of the LED also increases. But there is a limit. If too much current goes through the LED, it will be damaged and no longer light. The table below also lists the maximum current the LED can withstand before it is damaged. Normally, the maximum current of a 3mm or 5mm LED is about 20 milliamps. This table shows some generic LEDs. The voltages and currents can change, and you should have the data sheet or specifications for the actual LED you are using. But if I find an LED in a drawer or loose on my desk, I would just assume a 2-volt threshold voltage and 20 milliamp maximum current. When the LED is on, it has 0 resistance. If you built the circuit below, the 5-volt supply would give 2 volts to the LED. This leaves 3 volts and no resistance. If you use Ohm's law, you can calculate the current in this circuit. Because you can't divide by 0, 0.01 ohms was used instead. If you built this circuit, the current would spike to over 300 amps. Not milliamps, but amps. To prevent a runaway current in the circuit, a current limiting resistor is needed. The value must be calculated so the total current is less than the maximum current limit of the LED. The current limiting resistor will change in each circuit depending on the supply voltage, the maximum current the LED can withstand, and the threshold voltage of the LED. So, you need to calculate a new current limiting resistor for each circuit. Ohm's law is used to find the smallest resistor that is safe to use. After you calculate this resistance, you need to increase the value a little bit if you plan to build a real-world circuit. There is only one resistor in the circuit, and it can be found using Ohm's law. Starting with Ohm's law, the voltage across the resistor is the supply voltage minus the threshold voltage across the diode. We do not know the current or the resistance, so we will assume the current is the maximum rated current of the diode. Then you can isolate the resistor. The equation to find the value of the current limiting resistor is shown here. For this equation to work, the LED must be forward biased, meaning the diode is pointing in the direction of conventional current flow, and the supply voltage must be greater than the threshold voltage of the LED. Let's put all the pieces together. The LED shown here has a threshold voltage of 2 volts and a maximum current of 20 milliamps. First, verify the diode is forward biased, meaning the LED is pointing in the direction of conventional current flow. Second, verify the supply voltage is greater than the threshold voltage of the LED. Because both of these conditions are met, the equation to find the current limiting resistor value will work and the LED will light up. The LED will have the threshold voltage across it. This voltage is subtracted from the supply, and the remaining voltage is across the current limiting resistor. As before, the LEDs in these two circuits have a threshold voltage of 2 volts and a maximum current of 20 milliamps. The LED shown on the left is forward biased, but the supply voltage is less than the threshold voltage. This means you can't use the equation to find the current limiting resistor for this circuit, and the LED will not turn on. The LED shown on the right has a supply voltage that is greater than the threshold voltage, but it is reversed biased. This means you can't use the equation to find the current limiting resistor for this circuit, and the LED will not turn on. In both of these examples, the LED will not light up. The current will be 0 amps. And no matter what resistor you use for the current limiting resistor, there will be no voltage across it. Because the LED is acting like an open circuit, the voltage across the LED will be the same as the supply voltage. Here is the first example, and it is a very common problem. You often know the supply voltage, and then you pick an LED. You just need to find the current limiting resistor. Assume the threshold voltage of the LED is 2 volts and the maximum current the LED can handle is 20 milliamps. What is the smallest value you can use for R1 to light the LED without damage? Before you start, you need to check 2 conditions. First, verify the LED is facing in the direction of conventional current flow. And second, verify the supply voltage is larger than the threshold voltage. If both of these conditions are true, you can solve the problem. Using the current limiting resistor equation, plug the known values into it. In this example, the answer is 150 ohms. This is the answer to the question, what is the smallest resistor value you can use? A 150 ohm resistor is the absolute smallest resistor you can use, and it will allow the absolute maximum current through the LED. In practice, you do not want to max out the LED current. Running an LED at its maximum current is hard on the LED and may shorten its lifespan. In the real world, you would want to use a slightly larger value to reduce the current. Your choice depends on what you have available and how bright you want the LED. If this were my circuit, I would use a 220 ohm resistor because I have one in stock and the LED is still very bright. After a resistor value is chosen, a table can be generated. Start with the supply voltage and remove the diode's threshold voltage. The remaining voltage and the single resistor are used to calculate the actual current. 13.6 milliamps is about 68% of the maximum current. This will not hurt the LED, and it will be brightly lit. Here is example 2. As before, Assume the threshold voltage of the LED is 2 volts and the maximum current the LED can handle is 20 milliamps. What is the smallest value you can use for R1 to light the LED without damage? Verify the LED is facing in the direction of conventional current flow. And verify the supply voltage is larger than the threshold voltage. Because both of these conditions are met, we can calculate the resistor value. Using the supplied information, the minimum current limiting resistor value is 350 ohms. This is the answer to the question, what is the smallest resistor value you can use? In a real-world circuit, I would round this up to a common value such as a 470 ohm resistor. Using this new resistor value, the total current can be calculated. 14.9 milliamps is about 75% of the maximum current. This is a safe current and the LED will be bright. Not all LEDs have a 2-volt threshold value, and not all LEDs can handle 20 milliamps. In example 3, assume the threshold voltage of the LED is 1.6 volts and the maximum current the LED can handle is 15 milliamps. What is the smallest value you can use for R1 to light the LED without damage? As always, verify the LED is facing in the direction of conventional current flow. And verify the supply voltage is larger than the threshold voltage. Because both of these conditions are met, you can calculate the resistor value. The equation will give you the resistor value of 693 ohms. This is the answer to the question, what is the smallest resistor value you can use? A 693 ohm resistor is the absolute smallest resistor you can use, but this value does not exist. I would round this up to a common value such as a 1000 ohm resistor. Using the voltage across the resistor, the current through it can be calculated. In this circuit, the current is 10.4 milliamps. This is about 69% of the maximum current. This is safe for the LED, and it will be bright. I hope this video has helped you understand what a current limiting resistor is, how to calculate the value of it, and how it is used to light up an LED so the LED is not damaged. If you find these videos helpful, please like the video, leave a comment, and subscribe to my channel. This is the only way I can continue to make these videos.